Lesson 7.2, Division Properties of Exponents. In this video, you will learn to find the quotient of two monomials and simplify expressions containing negative and zero exponents. So, vocabulary, zero exponent, negative exponent, and order of magnitude. Okay, so the first rule that we're going to learn is the quotient of powers. So before, in the last section, we learned that when you multiply with the same base, so like if I had c to the 5th times c to the 3rd, I would get c to the 8th. In this section, we're learning division. So what if I had c to the 5th divided by c to the 3rd? Well, for addition, we added. So for division, we're going to subtract. So this would be c squared. So if you think about it, if you have something like r, we'll look at this one, r to the 5th over r2, right? So that's r times r times r times r times r. That's r to the 5th over r squared is r times r. So remember, if you have something when you're multiplying in the top and bottom, they cancel each other out. So this r cancels that one, and this one cancels that one. And what we're left with is r times r times r, which is r cubed. So r to the 5th minus 2 is r cubed. So you subtract the exponents when you're dividing with the same base. Okay, so if we want to simplify this, we want to do our like terms together. So we're going to look at the x's together. So x to the 7th over x to the 6th. So that's division. So 7 minus 6, right? So we're going to subtract our exponents, and I get 1. So I get x to the 1st. So I have y to the 12th over y cubed. So that's 12 minus 3, which will give us 9. So my final answer is x, y to the 9th. And that would be simplified. Okay. Okay, so if you want to pause the video for a second and try this, you should have gotten D. Okay, the next concept that we want to look at is the power of a quotient. Okay, so just like we had power of a power in the last section, like if I had A times B squared, that would be the same thing as A squared times B squared. The power applied to both of those things. It's going to be the same for division. So if I have 3 to the 3/5 raised to the power of 4, that 4 goes both to the 3 and to the 5. So I get 3 to the 4th over 5 to the 4th. And same thing with the variables. Okay. So for this example, anywhere that I have this thing separated by multiplication is going to get that power of 3 on both top and bottom. Okay, so I have 4c to the 3rd times d squared, and then that whole thing is raised to the 3rd. So the power gets applied to both top, and it also gets applied to the bottom. So I get 5 to the 3rd down there. Now here, this is what we were doing last section, where that 3 goes into each of those things. So I'm going to have 4 to the 3rd, c to the 9th, so 3 to the power of 3. You multiply exponents, because it's power to a power. And then d squared cubed would be d to the 6th. 2 times 3 is 6 over 5 cubed. Okay, and then you just want to simplify as much as you can. So 4 cubed is 16 times 4. Sorry, I don't have a calculator on me. So it's 24, and that's 64. So I get 64 on top, and then I get c to the 9th, d to the 6th, and 5 cubed is 25 times 5, which will be 125. Okay, and then if these things have any numbers in common, to reduce them, you would reduce 4 over 125. So that would be the power of a quotient. Okay, if you want to pause your video now and give this problem a try, you may do so. you should get B. Okay, the next concept is the zero exponent property. So this property says that if you have any number raised to a power or has an exponent of 0, it is equal to 1 every time. No matter what you're raising to the power of 0, you will always get 1. Anything to the power of 0 is 1. Okay, so if I'm looking at this, I don't even have to figure out what m and n are. This whole equation here, this whole expression is raised to the power of 0. So I can just say 1 and I'm done. Okay, if I want to simplify this, in this case, only the m is raised to the power of 0. So that's like 1. So I can replace that and say this is 1 times n cubed over n squared. And now I can do this here that simplifies with each other. So n cubed over n squared, I do subtraction. 3 minus 2 is 1. So I just get n to the first. And it's 1 times n to the first, which is just n. Okay, you can pause your video and give this one a try. You should get 1. If you try this one, you should get D. Okay, negative exponents. For any non-zero number a and any integer n, a to the negative n is the reciprocal of a to the n. Also, the reciprocal of a to the negative n is a to the n. Okay, to figure out negative this, we're going to say it's going to be the same thing as the reciprocal of 2 to the 4th. So reciprocal, remember, switches numerator. There's no option here. Reciprocal flips those. So this is going to be 1 over 2 to the 4th. So this here, 2 to the negative 4, is the same thing as 1 over 2 to the 4th. Basically, what it does, it takes anything with a negative exponent and switches it to the other side of the fraction and makes the exponent positive. So here, this is in the numerator. If you move it to the denominator, you change the sign to be positive. If it was negative, like in this case here, it's negative j to the negative 4. If you move it to the numerator, it becomes j to the positive 4, and it's like 1 over that. Okay? So, for example, a for 4. So if you simplify x to the negative 4, y to the 9th, and z to the negative 6. Okay? When you're simplifying, something that is simplified will not have negative exponents. So when you say it should be negative. So I want to get rid, so the way I get rid of it to the other, the negative. So if I want to get rid of that, move it to my fraction x, negative. I also want to move, this also has a negative. So if I want to get that, I'm going to move it to the other side, which means it comes up to the top and makes it a positive 6 instead of a negative 6. The y to the 9th is already positive, so I leave it right where it was. I don't move it. And now I have all positive exponents, which means it is simplified, and each variable only occurs once. Okay. For this one, I would say we're going to simplify this completely first. So what we're going to do is we're just going to go piece by piece. The numbers. So 75 over 15. We're doing 75 divided by 15, and I get 5. I'm going to go try it the next watching Q for Q is no, so still has to that have negative at the bottom of the equation. And else in the top. And only each variable once. Okay, so you guys try this one. And you should get A. For B, you should have D. Okay. Darren has $123,456 in his saving account. Tabo has $156 in his saving account. Determine the order of magnitude of Darren's account and Tabo's account. How many orders of magnitude as great as Darren's account is Tabo's account? Let's determine the order of magnitude.